be talking about tangents to a circle. Like I said, this is nothing to do with sine, cosine, and tangent, but it's the same word with a different meaning. So a tangent to a circle is a line or line segment that skims the edge of a circle so that it just has one point in common, and that one point is called the point of tangency. Okay, so there's going to be two theorems that we learn about this, and then some problems that apply those theorems. Sounds easy, right? Just two theorems, but there's a lot of little tricks to these problems, so we want to make sure that we pay close attention to how to approach them. All right, so the first theorem says if a line is tangent to a circle, at this point of tangency, if you connect the center of the circle to that point of tangency, you create that radius, that is automatically going to create a right angle. So it's perpendicular. The tangent line is perpendicular to the radius that it intersects. Okay? The converse of this is also true. So if you are told that there's a right angle there, you can conclude that it's a tangent line. So what does that boil down to? It boils down to this. If you are told that there's a tangent line, put a right angle immediately. If it says such and such is tangent to circle whatever, you should first think, okay, where am I going to put the right angle? All right? Tangent equals right angle, basically. So in this problem, ED is tangent to circle O. We put that right angle there, and basically we've created this triangle, which is a right triangle. If we have to find what X is, what are we going to do? X is the degree measure of that angle there. I do what? 90 plus 38 plus X equals 180. We are not going to do anything having to do with sides here. This is just angles, right? Adds up to 180. Therefore, we can solve for X there. Comes out to 52 degrees. Right? Make sense? Okay. So let's look at a couple of other examples. And this is where there's a couple of tricky things that come in. In this problem, they tell you that there is a tangent by putting the right angle in there for us. So we know it's tangent because there's a right angle there. They could have said BA is tangent to circle C, and we could have put the right angle there in ourselves. But here they put the right angle in. They're asking us to solve for the radius. They're calling the radius X in this case. This right triangle kind of extends beyond the circle, right? But the segment from here to here and from here to here are both radii of the circle. So they're both called X. Okay. So in this problem, yes, we can use the Pythagorean theorem. We have to be careful because we have, which one is the hypotenuse? Yeah, AC is the hypotenuse. What is the length of AC? X plus 8, right. So when we do Pythagorean theorem, we're going to do x squared, and don't write too big because you don't want to take up too much room, plus 12 squared equals the whole quantity x plus 8 squared, right? Because it has to be that whole hypotenuse squared. What happens when you do x plus 8, the quantity squared? It's x plus 8 times x plus 8, right? To square x plus 8, you have to multiply it by itself, and that's going to be a foiling situation or a distributive property. So when we multiply this out, we get x squared plus 8x plus another 8x plus 64. So essentially we have x squared plus 16x plus 64 equals x squared plus 144. Now the good news is there's an x squared on both sides. Why is that good news? Because you can cancel that out. Gone, right? We subtract it from both sides. Now we're just solving this, and what are we going to do next? Subtract 64 from both sides. And we get 16x equals 80. And x equals 5. There's no units here. So the radius of this circle is 5. All right, so there's a couple of things to remember here. First of all, the length of the radius is always the same. So when you label one radius x, the other one can be x also. Hypotenuse in this case, x plus 8. Sometimes people make the mistake of calling it 8x, right? You're not going to multiply. You're going to add those two segments together to get the whole length. And then, of course, you got to remember to FOIL. That's the big thing here. People often forget to do that. Okay, in number 3, it's asking us this question now. Is ML tangent? Is ML tangent? Well, how can we use that theorem to determine if ML is tangent? Yep. Good. We're going to basically test a squared plus b squared equals c squared. We're going to see if it works. So in this one, it's going to be 7 squared plus, which one is the hypotenuse? 25 is the hypotenuse, because if this was tangent, the right angle would be right here. So it would be 7 squared plus 24 squared, and we're going to see if that equals 25 squared. So that's 49 plus 5, what is it, 76 or something? So it comes out equal. So what does that mean? Yes, it's tangent. Because the Pythagorean theorem works. So there is a right angle, which makes it tangent. If the Earth is here, and you are above the Earth, so you go straight up and you're in this airplane right here, let's say, right? And you look out the airplane window this way, your line of sight right there, which we're calling D, is perpendicular to the radius of the Earth. So it's a tangent line, right? So it's creating this right angle. All you need to know is the radius of the Earth. And you can figure out how far it is to that point on the horizon. Oh, you also need to know, but you would know this because the pilot would come on and say, we're cruising at an altitude of blah, 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 right? And then that would tell you how high you are off the Earth, right? So this type of a problem is used to find that distance from some point. It could be you're up on a mountain and you know the distance to the horizon. In this problem here, let's do this one right here because they give us some numbers. The airplane is cruising at an altitude of 9,000 meters, which is 9 kilometers. So the distance from here to here is 9. The approximate radius of the Earth is 6,400 kilometers. So your line of sight from the airplane to the horizon is tangent to the circle of the Earth, so it forms a right angle right there. So now we can just do Pythagorean theorem. We've got d squared plus 6400 squared equals, and what's this whole length going to be? 6409, exactly. Right? So when you, that's all written out right here. So when you do the Pythagorean theorem, you're going to get the square root of this big number, and it comes out to about 339.5 kilometers from your airplane to the horizon. Fascinating, right? Yes, I know. Okay, but that's just, some application. All right, theorem number 2. So theorem number 1 was that a tangent line is perpendicular to its radius, right? So it forms a right angle. Theorem number 2 says if two tangent segments to a circle share a common endpoint outside the circle. So in other words, this AB is tangent to circle O, BC is also tangent to circle O, and AB and BC intersect right here at point B. This theorem says that the distance from that point where they intersect to each tangent line is the same. These two segments are congruent, in other words. Just erase that again. So, like I said, what does that mean we do? In this situation, mark these two segments congruent. Boom and boom. Always. Right? If there's a point outside the circle and two tangents drawn, then those two segments are congruent. Okay, so this actually uses the first theorem. If ML and MN are tangent to circle O, what's the value of x? We're talking about degrees here. So we could mark these congruent, but we don't really need the segments in this case. We need the angles. So what else could I mark in this diagram if I know those are tangent? Two 90-degree angles. Okay, now this shape is a quadrilateral. What do the four angles of a quadrilateral add up to? 360. So we're going to do 117 plus 90 plus 90 plus x equals 360. And then you solve for x. Anybody get it? What is it? 63, right? Okay, number 6, though, applies this second theorem. Circle O is inscribed in triangle ABC. Remember we talked about inscribed circles and circumscribed circles, right? A circumscribed circle goes through all the vertices of the triangle, but an inscribed circle is just inside so that it barely touches each side, right? So each side of the triangle is tangent to the circle, right? Each side is tangent. I'm going to write that here. To circle O. We want the perimeter of the triangle. So this is where we're going to apply that second theorem that says that the points are equidistant to the points of tangency. So B to D is the same distance as what? B to E. So we can label this 15. F to C is the same distance as C to E, so we can label that 8. And then A to D is the same distance as A to F, right? So if I mark congruences, it's going to look like this. So now we can get the perimeter just by adding up all the sides. Okay, so I'm going to have you try these 4, and then we'll check answers. And then when you're done with those, you can go on to the back. So these problems should have seemed familiar, very similar to the ones we just did. The measure of angle A is 58. That's here. Okay, we're trying to find this angle. It's just going to be triangle sum theorem. 90 plus 58 plus x equals 180, and x turned out to be 32. Okay, if BC equals 8 and DC equals 4, so we're doing this side is 8, this piece is 4, find the radius, these both have to be x. That makes this whole thing x plus 4. So remember, you need to do x squared plus 8 squared equals the whole quantity x plus 4 squared, and that has to be FOILed out, and it is x squared plus 8x plus 16. So this turns out to be the square root of 63, which as a simplified radical is the square root of 9 times the square root of 7, which is 3 root 7. So as an exact answer, your answer would be 3 root 7. As an approximate answer, it was about 7.94. All right, number 3 was straightforward Pythagorean theorem, just x squared plus 9 squared equals 12 squared. And that turned out to be, oops, did I do that one wrong? Yes, I did. That's this one. Sorry. Oh, dang, okay. Sorry, I put the wrong answer in the wrong spot. This one was square root of 63, which is 3 root 7, which is approximately 7.94. This one came out nice and even. X was 6. Yeah, radius was 6 there. All right, and then number 4. Your classmate insists that DF is a tangent line. So I saw some people checking Pythagorean theorem here and saying, well, yeah, it works. But yes, Pythagorean theorem works if this is a right angle, and you check Pythagorean theorem, 7 squared plus 24 squared should equal 25 squared. But that's not answering the question. The question is, why is it impossible for DF to be a tangent line? Yeah, because if DF was tangent, this would have to be a right angle. Can we have 2 right angles in a triangle? No, that's impossible. So, DF is not tangent because we can't have 2 right angles in a triangle. Okay, so for this one, remember that the 2 radii are the same length. So if this angle is 60, this angle has to be 60 as well because of the isosceles triangle theorem. So then we know this is 60 too. I mean, also. Therefore, this triangle has a right angle here, 60 degrees here, and x has to be 30. Okay, the rest of the answers are listed.